Right, today what we've got is this new kind of, I don't know, calibration come demo block, because we've gone away from the G name now to the Waygate. This one is similar to the other one, except it's got this Waygate logo instead of the G logo. It's got our flat bottom holes, 9 of them, at different sizes and different depths, and then it's got two other sections which are thinner than the back wall as well. Got our Mentor UT, and we've got our trusty 5 meg rotor array. So we'll just reach around here and we'll switch the Mentor UT on. Just takes a couple of seconds for that to come on. So let's just have a look at this. It's pretty similar to the old G one, except with this Waygate logo, and that's 10mm there, that's 6.5mm there, and then I've got 250 marked out between those two black lines to do the encoder calibration in a little bit. What else I need is a spray bottle with some water in. Just water in that, and then when the instrument boots up, we'll be ready to start. Okay, here we go. So the first thing to do is to select the app for this 5 meg rotor array. Any minute now. Okay, so it's none of these, so we just slide like an iPad over and find the one with a picture of a rotor array. It says rotor array 3.5, so we'll choose that one. We've got some options. We can launch, we can resume, or we can start from the setup page. So we'll start from the very beginning. So we've got launch, and we'll hit the OK. And there we are, it's loaded up. So it's got 10 pages in it. The first page is this cover panel, which tells you what are you going to be doing and why you're going to be doing it. I'm going to use these arrow keys to navigate. So just press the arrow key, move to the next page. So the application checklist tells us we need this rotor array. There's the part number, 64 elements, 5 megahertz, 1.6mm pitch. And then it tells us we need this calibration block, and it's got a picture of the old G block, but we've got this new Waygate logo block. So we move to the next page, and it tells you there, dead element check. Okay, so place the probe in the air and press calibrate. So I've got the probe standing up like this. And what it's using the reflection off the inside of the tyre to check for any dead elements. So this is the output of our elements from 1 to 64, and you can see they're all kind of a similar output. And use it on the A scan. We just got to make sure that they're in the gate, and then this little vernier button is the calibrate. And it said attach probe is good for inspection. So when you do something correct, it goes green. When it's incorrect, it's red. So I'm just going to fake now that some of these have failed by moving them out of the gate. Hit the calibrate again. Now we get this red message, and it tells us which elements are dead and the loss of sensitivity. So let's just put that back before we carry on. Hit that. So obviously you can see by the output of each element that they're all firing. So that's what we need. And we use the arrow again to move to the next step. So this is like a setup page, because we've got to deal with the tyre, the water path, the thickness of the sample, and a lot of things. So we've got our A scan, and we've got our N scan, or our frame view, but also we've got this little PDF in here, which zoom in, zoom back out, shows us the water path, the thickness of the part, and then it shows the time of flight of the ultrasonic beam and where to put your gates. So this does it left to right. Here's your initial pulse. This is red section is your IF gate, your gate A, the green gate covering the body of the part, and then the blue gate, the B gate on the back wall, just like that. So there's a little bit of explanation in there why you're doing it this way and how to do it. So I come back from there. So what we need to do first then is just put a little bit of water on the part, sit the rotor down on the full back wall thickness, tap the screen here and go into our ultrasonic settings and set some stuff up. So let's put a big range on here so we can see everything. So 100 mil, like that. And let's tell it to start from the initial pulse, the IP here. So now what you can see is, you can see, actually it's hard to see because these are in the way. So you can see the inside the tyre and the outside of the tyre reflections and the back wall reflection. So what we're going to do is just going to put this gate up a little bit like that so the inside of the tyre doesn't foul it. Just move that a little bit closer. Move that a little bit closer too. And then put our A gate in the area we're interested in. Okay, that should be pretty good for now. So let me go back down here, grab our ultrasonic settings. And now we're going to tell it that we're going to start with the interface gate, IF. And then we're going to put our range to something sensible for this inspection, 16 millimeters. Okay, that's pretty good there. Just move it around. Yep. So now we can see the signal from the back wall here, the signal from the back wall here, and this is just the top surface signal here. So we're pretty good. With the next page, we're going to do a velocity calibration. So the machine is expecting us to use the 12.7 millimeters back wall thickness for the velocity. But I think I'm going to use this step here just to show you how it changes. This step in here is 10 millimeters thick. So what I'm going to do, I'm going to touch the bottom here and I'm going to go to the settings and I'm going to tell it to use a multi back wall. So that's twice the back wall. And I'm going to tell it that that back wall signal is 10 millimeters thickness. And then it's already changed. Use 10 millimeters and press to calibrate. Just spray a little bit of water on the 10 mil thickness. Drive my roller up to it, like that. Just like that, in fact. And I can see my signal from is in the gate at 10 millimeters, but the repeat just isn't quite making the gate at a 20. And I've told it I'm going to use multi back wall, so I'm just going to bring that gate down so it captures it. Hit the calibrate again, and then the calibration velocity is 2740, and it's in a nice green window, so I know I've done it correctly. Moving on. So the next thing to do is a time corrected gain calibration. So for that I'm going to use, I think, this little step over here, which is 6 millimeters, and the back wall, which is 12.7. So handily for this one, we've got quick access toggles on the screen. So I'm going to TCG 0.1, I'm going to change that down to 6.5, I think that's there it is. Oh, too much. Like this. 6.5. And then move to point number 2. Point number 2 is going to be our 12.7. So I'm going to bring that down. Like that, and go back to number 1 to start, 6.5. So you can see it's already got the gate in the right position. Yeah, some water on there. Right. So our signal is in the gate at the right position, and we're just going to hit that calibration icon again. Record TCG for 0.1. Yeah, hit it again. It tells me it's recording. Now it wants me to move to 0.2, which is the 12.5, which is just the back of this part. So if I just step off here and I step onto it, so it's in the gate, I hit the calibrate again, it tells me TCG 0.2 recording, and then I get this green banner telling me it's done successfully. Now I can see the amplitude across all my elements is all kind of equal. And it's drawing this dark curve to represent the TCG on the screen. Move on to the next page, and its sensitivity. So it's looking for me to use something about 10 mil deep. So I'll just drive quickly onto that. Oh, and we're going to go. That's the 6 mil step. drive quickly onto that 10mm step like that. It's all nice in the purple zone up there. I'm just going to hit that calibrate button again, and then it tells me the sensitivity is complete. Okay, next step is the encoder calibration. So like I told you earlier, on this bit of plastic I've got 250mm already marked out. So I'm going to line my wheel up with that first line. I'm going to go into this box and change it to 250 because that's what I'm going to use. Enter. And then I'm going to hit the calibrate. It says move the scanner. So I move the scanner to 250. So I drive it down here, all the way down to this second line. A little bit too much. Okay, hit the cal. Tells me to move the scanner back to its origin. Just checking for any backlash, I guess. We drive it all the way back down to that line there. Hit the cal again, and now it tells me the scanner is calibrated and is within tolerance. So all the time we've been doing these things, the dead element check, the velocity, the TCG and the scanner, these things have been going to orange to green. So this one here at the top is still orange because we didn't do a delay calibration. And the reason being is we've got this water path and we've got the IF gate monitoring it, so we didn't need to do that. So everything's set up now. So the last page then, we move on to it, is the scan. So before we do that, I'm just going to move my gates around. So I'm going to go into my A scan, and I'm going to get my controls up first, like this. Make my range big enough so I can see my gate B a minute. There's my gate B lurking off the screen. Just going to put that over the back wall signal. Make it a little bit smaller, like that. And then I'm going to stretch my gate A all the way down here, like that. And last things last, I'm going to change that back to 16mm, something like that. Get rid of that. Double tap to get back to my main screen. Spray a bit of water on my part, and then I'm going to roll across the surface with my roller and collect the data as we go. Okay, pretty easy.